Well, welcome back to Einstein's train station with Einstein's thought experiment train. And what we're doing here is we're working through some of the implications of Einstein's assumption that the speed of light is constant for all observers. Now remember, Einstein came up with that assumption in order to preserve the principle of relativity, and that is that all motion is relative. The problem was that light provided this way that you could measure whether you're moving or not, and Einstein said, let's take that away. Let's assume that whenever you measure a light beam, it's always going to be travelling at c, the speed of light. So let's have a look at some of the implications, and the implication we're going to be looking at in this one is what happens to time. So if we're going to be talking about time, then we're going to need some way of measuring time. So what we have set up in our carriage now is a light clock. There's a light that sends out a pulse of light. It goes to the bottom of the carriage and is reflected off a mirror, comes back up to this device up here at the top, which is a sensor. It's going to give it a little beep, and it's going to send the next light pulse down. So effectively, it's a light clock, and of course it's going to be a way of measuring time. So we're going to be measuring time from this guy's point of view, and we're going to call that T0. In other words, not that he's stationary, we're going to say that the clock, the mechanism, the event that we're observing is in his frame of reference. It's stationary compared to this observer. So that's what T0 equals. If we think about speed is distance divided by time, and therefore time is going to be distance divided by speed. Well, we've decided that speed of light, that's our assumption. Everyone's going to measure it at c. Let's just say that capital L represents the height of the carriage. So T0 is going to be simply 2L on c from his perspective. Alright, so let's think about this not from his perspective anymore, but from this guy's perspective. And from this guy's perspective, what we've got is we've got the train zooming past him stationary on the platform. Except that the light beam is not going to follow a direct path. If we start the clock running and the train moves past him, you can see very clearly that the light beam follows a path that looks something much more like this, down and up. Now remember, this distance here, that's L, and so that distance down here and back up again has to be bigger than 2L. It can't be equal to 2L. So the time, from this guy's perspective, the distance has to be greater than 2L, but the speed, he's going to still measure that light beam at the speed c, which means, therefore, that T0 and TV cannot possibly be the same number. In other words, they are going to disagree about time. The person on the platform is going to see the clock in the train running slow. And just like everything in Einstein's Special Relativity, it's mirrorable. So the person in the carriage, if there was a clock on the platform, he would see the clock on the platform running slow. So they both think the other person's clock is running slow. So that's the end of the first part, where we've looked qualitatively at it. In the next part, we're going to look at this quantitatively.